Alright, for today's lesson, we'll be using your note packet. So why don't you pull out your packet and turn to lesson 3-6. This is on arithmetic sequences. Our learning target for today is I can identify and evaluate arithmetic sequences. So first of all, we have some vocab to get written down. Start off with sequence. So a sequence is an ordered list of numbers or objects called terms. And a term is an individual item in a list or sequence. So just think when we were doing like x plus 3 equals 5, the terms were x was a term, 3 was a term, 5 was a term. Now we're going to be saying that we have a different list. So kind of think about our list of the domain or the range. Each number of the domain could be a term. Each number of the range could be a term. Now an arithmetic sequence is a sequence that adds or subtracts by the same number. And that same number is called the common difference. It's the difference between terms in an arithmetic sequence. Alright, so I think this will make a little more sense once we jump into the actual work here. Alright, find the common difference in each arithmetic sequence. So we know in this problem here for A, this is an arithmetic, which means it is adding or subtracting by the same number. So what's it doing? It's going down by the same number. 11 to 9 to 7 to 5. Each of these numbers is a term. This whole thing is a sequence. They're telling us it's arithmetic because it's going down by the same number. The number it is going down by would be 2. But since it is going down, the common difference is going to be -2. That's all we have to do for these problems. So I can even go back and say -2 equals the common difference. Look at part B. 2.5, 3.75, 5, 6.25. So first of all, just looking through these, we can see that this number is going up. And again, we assume it's already arithmetic. They told us it's going to be that. So if it's going up, it's going to be a positive common difference. So all we'd have to do would be to take the second number minus the first number, or the third number minus the second number, or the fourth number minus the third number. They should all be the same number. They have to be. In that case, I can see if I take all those numbers, I would subtract, and I would get an answer of 1.25. So the common difference equals 1.25. Try C and see how you do. So we can hit pause. And now we are back. How'd you do for C? Hopefully you saw that this number was going down, so it's going to have a common difference of -2. Okay, now try D. Hit pause, and we're back. Looking through here, 4/3 is 1 1/3, and it goes up to 2 and goes up to 8/3. So what it's doing is it is increasing by 2/3. So the common difference would be 2/3. All right. Turn the page in your notes. All right, our next section here says find the next 3 terms in the arithmetic sequence. So again, we know that this is arithmetic, so it's changing by the same number by addition or subtraction. Now, as we can see here, it's actually going up, going from a negative number. Think of this as temperature, it's getting warmer. So 8 below up to 3 below is getting warmer. So how much is it going up by? It's going up by 4. So once we find the common difference, then we can just continue the sequence. So 7 plus 4 would be 11. 11 plus 4 would be 15. 15 plus 4 would be 19. And now we're done. That is the next 3 terms in the sequence. So technically, I didn't have to find the common difference to write it down for my answer, but I definitely needed to know that in order to find the next 3 terms. Okay, this next part. Now we're going to find a function that describes each arithmetic sequence. So in other words, this is like in our last section we talked about different ways to represent the same data. One of the ways was a table, another way was a graph, another way was an equation. So basically we're going to use a table to make an equation. So looking through here, what's going on? We can see this is going up, and it's going up by 6. So we can see here that we have a common difference of 6. Now, basically, looking through here, term 1 we can see is 6. Term 2 is 12. Term 3 is 18. Term 4 is 24. So we're just wondering now, let's just say, what could we figure out? What could we do to figure out what's going on with if we didn't have these numbers? Let's just say I wanted to find term number 25. I don't want to keep on adding up 6's forever to get to the 25th term. I should be able to just substitute in a number, like over here 25, into like an x and get an answer. So what's happening here is it looks like all we're doing is just taking the x value and multiplying it by 6. So all we're going to do is say our sequence or our function is going to be 6x. Now a way to test this is to go back and look at some numbers that aren't on this list. We've been saying all along you should be using the number 0 because it's a good one to check out. What if we use 0 in here? 6 times 0 would be 0. Now look at this pattern. It's going up by 6 for each term. Now if we go back, what will be 6 minus 6? It would be 0, so it does check out. Try this one and see how you do. Hit pause, and we're back. So hopefully you noticed that this one was going down by -4 was the common difference. So it's getting lower, and I can see that my first term was -1. I'm sorry, -4. My second term was -8. My third term was -12. And my fourth term was -16. So what did I do? I just took my x times -4, which happened to be my common difference, -4x. And this is my function, or my equation, y equals -4x. And this should work out. 4 times -4 is -16. Yep, it does work out. If I were to go backwards, so this was here, this was going down. So to go up another 4 from here would be 0. -4 times 0 would be 0. Yep, that did work out. Okay, now let's check this one out. A DVD cost $3.95 to rent plus 45 cents for each day it is returned late. Find a function that describes the arithmetic sequence and then find the total cost of renting the DVD and returning it 9 days late. All right, so a couple of things we could do here. First thing I would do is to make a table. So think about this. On day 1, and I'm just going to do this, I'll back up. This is going to be my x, and this is going to be my y. Okay, so on day 1, so far, I have been charged $3.95 for this DVD. Now, on day 2, I will be charged an additional 45 cents. So I'm going to take that. Thank you. Actually, we're going to look at this here a little bit differently. These numbers over here would be how many days late it would be. So actually, if you're looking at this, on day 1, that's actually 1 day late. So let's even just think about this instead. On day 0, this is 0 days late. This would actually be a better way of looking at this problem, saying at 0 days late, it just costs $3.95. Now, on 1 day late, so instead of looking at it as days, we're looking at it as days late, it's going to be $3.95 plus 45 cents, which would give you an answer of $4.40. Now, day 2, same thing. It's going to be another $4.40 plus 45 cents, which would be $4.85. If we kept going, see if I can, day 3, we're just adding in another 45 cents. So $4.85 plus 45 cents would be $5.30. I could keep going to 9 days late, but I hope I can see a pattern here. Going through here, our common difference is going to be 45 cents. Now, thinking what we did with the common difference before, we multiplied our common difference by x. If you look back at the last 2 examples, that's what we did on the previous page. But in this case, there's a little bit different situation going on here. So 0 days late is 0.45, so 0.45 times 0 would be 0. But you are charged something on day 0. So what you're always going to do is add in the initial cost of $3.95. So now this would give you 0.45 times each day late plus the initial charge of $3.95. So now using this equation, we're going to jump down and we're going to wonder what is y equals 0.45 times 9 days late plus $3.95. And if we go to our calculator, go ahead and calculate that out. We should get an answer of $8. So that means y equals 8. So in this case, that would be $8 for returning the DVD 9 days late. And that is all.